going to be covering some SolidWorks surfacing tools and skills, some tips and tricks on how I use surfacing. We'll talk a little bit about some organic shapes as well. Um, my name is Kaylee Gonzalez. I've been an applications engineer for MLC CAD systems for 12 years. I had my 12th anniversary this September. And then before that, I worked as a metrology applications engineer for about 3 to 4 years. So I got to work on some pretty cool stuff when I was in metrology. Like we worked on the first iPad mini from Apple. The company I worked for, developed and integrated their metrology process in their China facilities. So I got to work on some really interesting things. I used to say I used to work on Samsung, but then they all blew up. And I was like, that wasn't me. Don't blame that one on me. They haven't done that for a long time, but they did right around that time. And I was like, nope, I quit. That was not me. So what I'm going to talk about, I have two kind of main examples about surfacing. And when I talk about surfacing in SolidWorks, I like to think of surfacing as like a set of tools that I have. And I use it a lot in conjunction with solid modeling. When people think of surfacing, they think of doing like an entire model in surfacing. And of course, sometimes we have to do that, but I like using it in some other ways as well. Now, also when we talk about surfacing, we could spend sometimes several hours just sketching things, getting things set up. And I didn't want to do a presentation where you watch me sketch things for like 30 minutes and accomplish nothing. So I have a couple other examples that I'm going to cover here. And the first one is how we can use surfacing to get rid of some of those pesky additional like seams and edges that we get in faces where we may not know why they're there, but if we have that file and send it to someone who's using a CAM software, they're not going to like those seams. So we'll see an example of how we can go ahead and clean that up using some surfacing tools. So what we're going to see here when I jump into SolidWorks is actually this drill bit. And so what we have here, and I'll zoom in when I jump into SolidWorks, but there's this little black face. That's a little tiny flat face that was part of how this like helical surface was actually created. That, and we also have like that line through the middle that is actually not something we want to have. And we can see from the color mapping that the transition from green to brown, there's that sliver of green in the middle. It's actually not as smooth as we could potentially make it. So what we're going to do is use some surface modeling to have something closer to this, where we don't have all those extra lines. We have a much seamless and symmetrical type of color mapping for our contours. So let me go ahead and go into SolidWorks here. And we have this example. So as I mentioned, we have a couple of things. One is these little tiny faces. There's a couple of them here. There's also these faces that have been segmented out. Now, a lot of times we may not realize why this happens inside of SolidWorks or any other CAD model. A lot of times it has to do with how something was made or how something was sketched. If you sketch something, usually wherever there is a point, you could introduce an additional seam or it splits the face. That's something to keep in mind. Now, in this scenario, how they did this helical cut is they had a separate body that they did like a swept cut, and the actual edges from the tool body as it got swept across actually kind of projected into the model itself. So it probably was not the cleanest way to make it, but maybe it was the most accurate. So I'm going to start by deleting the circular pattern. I'm going to do this on one, and then I will repattern it at the end. Now, when we have these little tiny faces, there is actually a surfacing tool under delete face that can help you clean those up. And so over on the left, you have delete and patch rather than just delete. If you choose the delete and patch for these tiny faces, what SolidWorks does is it actually extends all the faces surrounding those, and it simply just patches them up. It's one of the easiest ways to clean up little things like that without doing a lot of effort. I use that probably way more than I should probably admit, but that's like a little unsung hero Now, a couple other things here that I want to do is I'm going to actually recreate essentially these three surfaces, but as one surface. And what I'm going to do is I'm going to use some of the existing geometry that's here to set up my sketches so that I can eventually use a boundary surface. So if you notice in your surfacing tools, there's like an extrusion, a revolve, a sweep, a loft, and a boundary. They work identically to their counterpart features in the features tab, other than we can sometimes use open sketches where you can't do that in the features tab. Now, to get a lot of these sketches that I have or that I need to have for this boundary, I'm going to start by creating a plane. And what I'm going to do here is I can actually make multiple planes at a time. So I use this again very frequently when I have to create a lot of lofts, boundaries, because you usually have a lot of intermediate sketches. I've worked with up to 20 sketches in a single feature before. 3D sketching is going to become one of your best friends. 3D sketching is great because you're not bounded by a plane. And so we can tend to do a lot of things. Under the convert entities is a feature called intersection curve. This is something that I do see as being underutilized. What this allows me to do is I can choose my three planes, my three faces, and SolidWorks gives me a perfectly fit set of splines exactly where those items intersect. Now, when I actually create these, if I hover over them, SolidWorks did create them as two splines instead of one. And it did that because that seam there is in the middle. So now we're like, well, great. Well, I like to use something called the fit spline. This is one of the easiest spline tools to use in SolidWorks because really what it does is you can actually select two or more splines. It fits a perfect singular spline over that and makes the original construction geometry so you don't lose any of your sketch relations. So now if I click on this, see how it's one continuous spline. So I'm going to do that for these other ones. So this actually has three sections in it. And I have a couple other items that I need to convert. So I need to convert this end because this is going to be one of the kind of profiles for my sketch. And I'm going to do these other edges. So right now I'm essentially making copies. Now here, this section in orange, this is kind of a really weird section in comparison to everything else that I have. So that would actually be problematic when I try to do anything with surfacing with it, because it's going to kind of try to overlap other items that are there. So what you can do is you can also use a tool called split entities. You can use this to split any sketch entity into multiple entities as needed. So for example, I'm going to kind of line this up pretty close underneath. This does not have to be exact, although you could add dimensions to it if you wanted, and see how that just splits that segment. I have a couple more splines that I have to create under my fit spline here. So I'm going to choose those three there, and then I'm going to combine these two. So again, I'm just kind of cleaning up some of these edges. And so I have almost like a replication of kind of the fundamentals of my geometry, but a little bit cleaner. So I'm going to just delete those faces that I know are bad. Let's just delete them out. The delete face feature in SolidWorks is really the only feature that converts a solid into a surface because it makes it no longer volumetrically like airtight or watertight. So this is now completely open, just a set of surfaces. But all my sketches are there because of how the SolidWorks tree goes from the top downward. So if I go into my surfaces tab, I'm going to go into my boundary surface. Now, if you've noticed, I had almost all of those in the same 3D sketch because I like to use my selection manager. So I actually have way less sketches. I don't like having to manage like 100 sketches that have like one singular purpose. It gets too confusing too fast. So I can put a lot of features grouped together inside of a single 3D sketch, and then I can simply choose the open groups and the different segments. And so here I'm going through and just creating this surface. So you can kind of see here on the end why I segmented that, because that just filled that in very, very nicely without overlapping a lot of information. So if I were to take a look at the curvature, looks pretty good. We even have kind of a little section. It's very symmetrical. And even though we do have a little bit of kind of a curvature, kind of quick shift and deviation, it's not black. Black faces are 0. So that was black when we started. When we start talking about surfaces, right now I have 2 surface bodies. The end goal is normally to have a solid. So the knit surface allows me to choose 2 or more surfaces. And again, if they are volumetrically airtight, I can say create solid, goes ahead and creates a solid. To finish this up, we'll just do a circular pattern. And what I'll do here is I'll do the face. We don't see faces and patterns very much. Usually we see features and bodies, but this will actually give me that last face that I need just to duplicate all my effort. And so now we have a much cleaner face without all the extra lines. So it's a little bit of effort, but one thing in there that I did is the 3D sketching along with the intersection for that, and then being able to recreate that geometry. So this is something that I show people very frequently. I do like a rotation on tech support at my job. MLC is a SolidWorks reseller, so I do a lot of tasks, but I still go through my rotation on tech support, and I get questions about how do I clean this up? How do I get rid of these like extra little edges? And this is one thing to be aware of, and it's done through just some very basic surface modeling.